Welcome to Abrar Electrical World. This is a video about the trip circuit of circuit breaker. I have made and uploaded already this diagram with my lecture in the classroom in the workshop. Then I thought that I should also upload this video in a PowerPoint presentation form, and there should be some written comments as well. So therefore I decided to upload it again. The content will are same, but because I am recording again, so there may be some additional information or maybe something left. So this is just a supplement to that one, which was a classroom lecture. So in this one, you will see that the diagrams will be more clear. And let's start. See, I've written here something that trip circuit is simpler than closing circuit, and the gas pressure interlock is must as in the closing circuit as well. The drawing shows one trip coil, but some cases there are three single pole on off arrangements, especially when we have the breakers about 245 kV and above, then there are three single pole and there is a separate operating rod for each of the poles. There is no common operating rod as in case of usually in 132 kV circuit breaker. Similarly, in GIS also they are independent. So when they are independent, there is an advantage that you can use the reclosing as single phase, two phase, or three phase. So single phase reclosing is possible only when the operating rod for each of the pole is independent. So in that case, when everything is independent and the operating rod is not common, we will need three tip coils, each for one phase, one for each phase, and also the three closing coils for one for each phase. So in total, the three tip coils and three closing coils. But in the picture, we always draw as a single line diagram, and we will show just one trip coil and one circuit, and that will mean that if the voltages are higher and there is no common operating rod, then there will be three similar diagrams on the pages if you go through the drawings from the supplier, contractor, or bidder. So this is to clarify that don't think that it is always one trip coil. There may be one trip coil for all the three phases, and there may be three trip coils. That's one trip coil for each of the phases, and similarly with the closing coil. So therefore, I am explaining you that this is a single line diagram showing one pole, and keep in mind there can be two, there can be three trip coils for one for each circle. And similarly, when we go above 245 and also in 245, you can also you will also see that there are two trip coils for each pole, two trip coil for each pole. Remember, and two batteries, two set of batteries as well. So that circuit diagram I will discuss separately. Here I am not mixing up, but just explaining to you in case you come across a drawing where you have the two set of trip coils and two set of the batteries, and there is another third type of the tripping. If the both the batteries fail, then ultimately there is the arrangement with the charge capacitor, and the breaker is tripped by the use of the DC from the capacitor. So this is the circuit. You know, the circuit is for the, this is known as the secondary wiring, and this is a 220 volt DC. It may be 110 volt DC as well. So you can have 220 volt DC or you can have 110 volt DC. So this is the common to the closing circuit as well. But here you see this is for the manual closing and manual tripping. So these switches remain same as in the closing circuit. Only difference is that you will use this this position for the tripping or this position for the tripping, and local and remote selection will remain same. either you select local or you select the remote. But when you will draw the trip coil tripping circuit diagram, you will show it like this, that this should terminate here on the T. T. In the closing circuit, it will terminate here on the C. So this is the difference in the diagram, but otherwise this equipment is similar and installed on the control panel right here. And the protection panel, you will have the relays. Like this 86 is the master trip relay. This relay I will explain in a separate video I upload immediately after this one by tomorrow. And this is the contact of the master trip relay, which is device number is 86. Now this 86 relay I will show you separately on a drawing and explain to you. But for this circuit, you must remember that the tripping is coming from all the relays to the coil of this relay, and this is the contact of that relay. Which relay? The 86 relay. What is the name of that relay? That is name is the master trip relay or the lockout relay, and this relay is manually settable. It is not automatically, it is not set automatically, it doesn't set automatically, it is manual set. So I will explain this all in detail. For here you should remember that this is the contact of that 86 relay, lockout relay, not the lock relay itself. Here it is the contact of this. When the relay will be energized from the differential relay or Backus relay or any other relay, then that coil will be energized and this will be on. So this is the normally off position. And see, the tip is coming directly here. You will have the pressure switch here. It should be closed when the pressure is okay. I have shown here another contactor here, that is K10. Now this is a this number is used in the Siemens drawing typically. What happens that the SF6 pressure switch has very small contacts and maybe the very low amperage contacts. So another contactor is used, and this contactor or this relay, auxiliary relay, has a contacts. One of them is shown here, and these can carry a more amperage, maybe 1 ampere. So this contact is now the contact of this relay K10, which is energized by the SFC's gas pressure relay. So this is the gas density meter or gas pressure relay. It is also known as the gas density meter. In some drawings you will see gas density meter, and some you will see the gas pressure relay. This will actuate the pressure is okay. It will be energized, and when the pressure is okay, it will not be energized and the contact is closed. If this is open here, then this will work when energized. It depends how do you draw the logic. Anyway, it is a in-between auxiliary contact which has a heavy contacts, and one of them is used here. When the gas pressure is full, then this is on. Similarly, spring is there and the breaker normally open contact, because when the breaker is closed, this will also be closed. Here, so for the tripping circuit, it is closed, so it will be closed. But the closed, not the closing contact, but it is a normally open contact which will be closed. So the circuit will be through and the negative is already there. So this is the circuit diagram of the tripping circuit of the circuit breaker. So I hope you have understood it, and I have added something here. I have explained something extra here. So if you go through both my lectures, one in the classroom workshop type and this one in a PowerPoint type, I will think they will supplement each other. So please subscribe, share, and like my channel. It is totally voluntary job, and it is for the benefit of the engineers.